I'm going to talk a little bit about AWS. I'm going to talk a little bit about infrastructure, what that means. I'm not assuming too much prior knowledge about systems or infrastructure or DevOps or anything like that. So I'll spend some time making sure that all of that's defined. And then from there, going to show how you can use this interesting library called troposphere to actually build infrastructure as code using pure Python. So I mentioned a little bit about what I do a few minutes ago, but I own a consulting company focused on DevOps, Kubernetes, cloud type things. So if you are interested in this area, please feel free to ping me in the Chippy Slack. Or if you work for a company that's looking for these types of things and need help, I'm happy to, talk business. But I'm involved. I've been involved for about the last 3 years in a lot of open source stuff related to Kubernetes and containers. Kubernetes is if you're not familiar, is a platform for running containers. And if you're wondering what's containers, if you know anything about Docker, Docker is pretty much synonymous with containers. I'm one of the maintainers of a project called Helm. Helm is a package manager, which you can think of like Brew or apt-get or Yum. That is specific to Kubernetes. So if you're installing applications into Kubernetes, Helm is sort of the de facto tool you would use to do that. And this was, I got involved. I got involved with that project a few years ago when I developed a project called Chart Museum, and that was since adopted as part of the Helm project. And like I said, I'm mostly doing Go today, but there is a very special place in my heart for Python. It's my first programming language, and I think it's the absolute ideal first language for anyone to learn. And my favorite quote, I think, is from T from the user group, which is, Python is the second best language for everything. What is, if the title of the talk had AWS in it, you may not know or be in the space to know enough what that is. What is AWS? AWS stands for Amazon Web Services. So this is the company Amazon. When you go to buy something on Amazon.com, this is the same company. I heard a statistic semi-recently that Amazon Web Services, the revenue that they're actually getting from this has surpassed what Amazon has made on Amazon.com, which is pretty unbelievable. And when people talk about the cloud, a lot of times they're referring to Amazon, or they're referring to Google's cloud, or Microsoft's cloud is called Azure. And there's several other kind of smaller ones, DigitalOcean. But I would venture to say 75–90% of the time we're talking about AWS when you talk about the cloud. So Amazon Web Services, to recap, it's just one of many of the cloud providers that are out there. And what is a cloud provider? It's a company that you pay to run your code and the backing services that support your code. It's very widely used. Like, it's probably more widely used than you think. Like, if you're gonna, after this session, go watch something on Netflix, Netflix's entire infrastructure runs on top of AWS. And you have to think about the scale of that as they're serving video content all over the world, 24/7, 365. And on that point, Amazon does have physical data centers, places where they have thousands and thousands of servers scattered all over the US and scattered all over the world. So if you're deploying an application that is for, I don't know, a soccer team in Ireland, you're going to probably put your servers in Ireland. And there's also ways where you can do interesting things where you deploy a version of your code in different locations, and based on where you're requesting the website, it will use the server that's closest to you. And one of the things that I think a lot of cloud providers have this, but I think one of the things that sets AWS apart is that they're very much API first, meaning that the APIs to do cloud stuff in Amazon are built in such a way where it's very programmable. You can write a client. They're very well documented. You could write a client to work with this API. And as far as I understand, the API, when they're building new services, they're actually working from the API up. So the actual console, the UI that you can click around in is sort of secondary to the API. So infrastructure, what are we talking about when we say AWS infrastructure? Are we talking about roads and the industrial infrastructure, you know, of the city of Chicago and trains and things like that? No, we're not talking about that. We're talking about your servers and anything else that provides, that backs that application up. So on the right side of this diagram, you see there's a database server. So think about MySQL, MongoDB, things like that. DB caching servers. So if you've ever used Redis or Memcached. And then on the left, like load balancers are things that will spread traffic. So if you have a heavily used website, if you want to spread traffic across, let's say, 10 different servers running a replica of your code, a load balancer does that. And if you're just watching this and you know Python and you know how to write a Python web server, if you've used Flask or something, in this diagram, this is actually the location that your code will run, whether it's you know, running just with a daemon or as a container. Ultimately, it's on an application server somewhere. But there is a lot of logistics to how you're routing requests when someone goes to yourcompany.com and getting the request all the way there and back. So we're talking about, when we're talking about infrastructure, we're talking about things that run your application and the things that support it. It's a general term for parts of your product of your software product that isn't the actual code. If your application uses a database, that's infrastructure. If it uses a cache, that's infrastructure. And I think this is a little bit debatable, but even if you're familiar with serverless and Lambda and things like that, you could even consider the function as a service, like the Lambda function, as infrastructure itself. So with Amazon, how are you going to provision the infrastructure? Well, I said that they have these great APIs. So really all you're doing is you're going to make an API request over HTTP to request that they provision a service on your behalf, and then they charge your credit card, and that it's done. And the easiest way that you can do this is by logging into the Amazon Web Console and click around. So here's an example. This is a screenshot of when you're within the Web Console. this is sort of the portal that they have, where if you want to launch an instance, and you can see they provide you different types of instances. They have these different sort of tiers, and they have small ones with just one CPU up to a ton, right? So, and the way that they sort of, their business model is the larger, typically the larger, more, the stronger the instance, the more CPU memory, throughput, et cetera, the more expensive they are. So, and what they do is, it's different than if you sign up for like GoDaddy or something like that, where you're paying like monthly, maybe $20 a month for this WordPress site. I don't know. With Amazon, it's very specific. Like, you're paying fractions of a penny per hour, which actually, you know, if you think about the number of hours in a month, could end up being hundreds, if not thousands of dollars. And, you know, bigger companies have pretty large AWS bills in the tens or even hundreds of thousands of dollars per month. So what's wrong with going to the AWS console and clicking around until you have all of the services or servers that you want? There's nothing really wrong with it. In fact, if you're provisioning maybe one server, something like that, it's not so bad. The problem is that one click quickly turns into many clicks. Let's say you're providing 5 different services. There might be, you know, 3 different screens per service while you're provisioning these things. And on top of it, for everything that you provision, you are on the hook to pay for, right? There is actually, if you're interested in just trying out AWS, I think you do need to put a credit card in, but there's something called the free tier, and you can actually, if you're using small enough instances, not pay for a certain amount of time. But I'm not here to sell you Amazon. But beyond that, there's over 100 different services located inside of Amazon. So you better hope that you remembered all of the things that you've provisioned. Otherwise, you're going to end up paying for things that you completely just forgot about. And it's complicated by the fact that you can create a server in this region, and it doesn't show itself. It doesn't show itself in the portal, because you have to transfer regions to switch between portals. So if at one point you went and launched an instance in India, I'm not checking my India region every day, and maybe that thing stays running and you end up with a bill. And then on top of it, like, some of these services require that you've provisioned some things ahead of time. So you get to the screen and you go to create something, and it says, well, what's the security group you want to use? What's XYZ that you want to use? And so you end up jumping through all these hoops to get all these things deployed in such a way that it's you know, you're just trying to get your server up, and you're not really thinking about these different pieces, to the point where if you wanted to actually remove everything, you need to remove them in the same order that they're created in that dependency tree. So it can get a little bit hairy like that. And then this clicking things, especially for a productionized environment, is sort of anti-DevOps. And DevOps is essentially, you know, there's sort of a lot of confusion and disagreement about really what DevOps means, but this is my own definition, is that it's the improvement and automation of everything between the time that you make a change and commit it into Git or GitHub, and between that occurrence and your code running in production. So like Andrew was showing with PyTest, that's could be considered DevOps. You're taking code that's been checked into GitHub, running tests against it. You might build a container or build a server image, an AMI, and publish that somewhere, and then deploy your thing. That's sort of DevOps. So if you're clicking around and creating servers, you're breaking many rules of DevOps, where all of this should be automated. And I think that I heard this quote somewhere, but now I'm starting to think that maybe I made it up. But it reflects a lot of different things that I've read. But the maturity of your company's DevOps can be measured by how quickly you could completely rebuild your production environment from source code alone. So let's say you have your Amazon account or your server room just completely dies in a fire, burned to the ground, and you have nothing but your source code on a USB stick. Doomsday scenario. But what would it take for you to get your website back up exactly like it was before the fire started? And that is why we need to use something called infrastructure as code, which I'll talk about on the next slide. So how can we do DevOps on AWS? So there's sort of three primary options. If you know of anything else, please say so in the chat. Or if your company's using something else, please say so. The most general one is AWS CloudFormation, which is what I'm going to talk about tonight. And what AWS CloudFormation is a way to define all of your AWS resources in one JSON file. And what's great about that is that you could deploy everything and undeploy everything in one fell swoop or all at once. And that really solves the clicking around issue, right? Then there's also Terraform, which is a great tool. It's made by a company called HashiCorp. If you're familiar with Consul, CONSUL, or Vault, they're the same people that make those tools. And then Amazon provides a command line interface. It's actually written in Python. And depending on how simple your situation is, and I actually use this more times than not, is just writing a simple bash script that calls the Amazon CLI and deploys it. You just have to make sure that you're the inverse of that script that undeploys a thing is doing all the right things, which is what makes CloudFormation and Terraform sort of the better long-term option. So CloudFormation is Amazon's official solution for infrastructure as code. So infrastructure as code, really all that it means is that you're storing and versioning your configuration files for your infrastructure exactly the same way as you would version and store your Python code in a Git repo. So it's if you understand why you're using Git and why you're using GitHub, it's exactly the same concept, exactly the same value add, but for infrastructure and not for your source code. So an example of this, if you're super mature with this, you could have, let's say a developer on your team was tasked with adding caching support to your application. So like support for Redis, for example. if you're not familiar with Redis or caching, it's just a way that the state of your application is stored even if your server goes down, or if you're running multiple servers, they could share state between one another. It's for speed and reliability purposes. But let's say you're trying to add that support in your Python code. So you would import some Redis library. And you would make, from your Python code, make a connection to a Redis instance and cache, store, and retrieve stuff from the cache. But in your production environment, you would still need to create a Redis instance. And so what you can do is, in one single pull request, submit the support for Redis, as well as the actual production infrastructure of the Redis itself, in a single commit. And it's just so much more reproducible than clicking around in the Amazon console and hoping to remember what you've done. There's obviously hiccups, here and there, if like AWS has updated something, or you have the wrong version of the Amazon CLI. But I would say more often than not, it's pretty reliable over long periods of times, like over years. So this is sort of an example of the beginning of a CloudFormation JSON. And you may be looking at this and thinking, that doesn't look like something I want to touch or work with, right? So you may be asking, I don't like to edit 5,000 plus line JSON files. They're not always this large, but if you have some pretty advanced infrastructure, they can get quite large, and you better hope that you have all the right quotes and the right commas and the right curly braces in all the right places. And I agree, this is not a way to live your life. And so there is a way that this can be made easier, and that is that you can use Python. You can use Python to generate that JSON using a really cool library called troposphere. So I am going to switch out and do a demo here. If you want to follow along, I have a public repo here, which I will throw into the YouTube chat as well. But all the source code I'm about to show, if you want to follow along in your browser, if that's easier for you, you can go here and yeah, everything that I'm going to show in my editor is right here. So let's take a look at some of the files I have going on here. So this is the CloudFormation JSON that we're going to build. It's not 5,000 lines, but let's see how many. 90 lines, not so bad. All this does, it's as simple as it gets. And to be truthful, it's a really bad example of why you would use CloudFormation, but I wanted to show a palatable example with this. So it has all these custom fields, mappings that you can reference later in the file, region map. If I look elsewhere in the file for region map, you can see it's trying to. They have all these special JSON fields where you can actually go fetch things from other parts in the file. It's actually pretty brilliant and well made, but again, like, this is not something you really want to edit by hand, although at one of my jobs, that is actually what I did. So it has the concept of outputs. So once you've created your CloudFormation stack, it's called, it will tell you all these different things about your stack. So, for example, what's important to us, the public IP address. So this is going to deploy a server, and it will spit out the public IP of that public IP address of that, so that you can from a script or something pull that out and pass that along somewhere, maybe send it to a Slack channel or whatever you need to do. And then finally, resources. These are the actual things that you're going to the services you're going to deploy on Amazon Web Services. And right here, all we have is EC2 instance section defined, and all we're doing is creating a single instance of this size, and this size has a certain CPU and memory associated with it, and a certain cost associated with it. Key name Chippy. This is a SSH key if I wanted to get into that instance, and all sorts of other fields that are probably not even defined here. It's very customizable. Amazon has a lot of documentation on how to use raw CloudFormation. But let's take a look at troposphere really quick. So troposphere is pretty neat. What it allows you to do is import a few things here. So import troposphere EC2 as EC2. EC2 is on Amazon just servers. It's the most basic unit from Amazon Web Services. But like, this is as simple as it gets, right? Like, you could start a template, a CloudFormation template. Let me zoom just a little bit more. Create a new instance using the EC2 library. Set the image ID on it. AMI are sort of like base images, so there's all sorts of AMIs. You can get ones for using Ubuntu or using Fedora or whatever your Linux distribution of choice is, and the type of it. And then you add the resource to the template, and then it provides this to JSON, which will spit it out to standard out, or it will return a string, and then you can print it to standard out of your template. So from there, then you could take this JSON, and for example, if you go to Amazon, this is the Amazon console. If I were to be a clicky type person, I could press create and walk through here and say upload a template file, and put that JSON file here. We're not going to do that because, again, anti-DevOps. But what we will do is write a tiny script. So I have and this is all in that repo, build CloudFormation JSON.py. So I'm importing all of this stuff from troposphere. And this actually, in full transparency, is just an example here that I've modified a little bit. So if you go to the troposphere repo, it's under Cloud Tools Troposphere. I don't know what company this is associated with. I think it's actually truly an independent project. But if you go to the examples folder in here, you can see all these different examples for how to deploy or how to build CloudFormation template for all these different Amazon services. So DynamoDB, which is similar to MongoDB. ELB is an elastic load balancer. All sorts of stuff here. If you wanted to write a Lambda that deployed your Python code, you could look at that. But anyway, back to our script here. So I'm going to take an environment variable. This was part of the modifications I made, called message. And the hope here, I'm having a few issues getting this to work, so I really hope it works for the demo. But take a message from the environment that you want a web server to say back to you when you run the web server. So creating a template, this is how you start a CloudFormation template with troposphere. I'm adding a mapping, so this is what that is. And keep in mind, this JSON file we're looking at is the actual results of running this script. I'm going to create or add to the template an EC2 instance with all of these different fields. That whole thing to kind of determine the region or the correct image ID for the region. It's really interesting. I mean, so you can deploy in these different places all over the world. So if I say I want to go into US East 1, it's going to use this base image. And so this really just builds out that section that references the key value, getting the AMI key out of the object returned by passing in this region. I'm hard coding the instance type just to keep it simple. This is a key name. This was the one thing I did click and create ahead of time just for the sake of the demo. But you could actually create an EC2 key pair called Chippy prior to the EC2 instance and pass that in kind of like we do like that. The default security groups is a security group in the account that's when you create a new account that's there by default. I made one other modification. I know I'm sorry that exposes port 80 so we can run a web server and hit this instance remotely. And then user data. User data is an interesting thing in Amazon, which is when your server starts up, run this stuff. And I'm doing what seems to be, or I thought was very simple, but I'm having a few issues. But I'm making a directory called web server on the file system. I'm creating an index HTML file, which is the root of a web server. And then I'm using this Python simple HTTP server to start a web server in the web server directory. And then this little and thing to kind of exit the script and go in the background. I think this is the source of my problems. You really want to use like a true daemon type thing to run your code. And then you can define the outputs. So these are things like the public IP. This is the really important one that we want to expose. And then all I have is a bash script. And I can just walk through really quickly. This command is the Amazon CLI. So you can install this with pip. You can pip install AWS CLI if you want to. It's creating a virtual environment and installing troposphere, which is defined in my requirements txt. And then it's going to run the script and pipe the output to a file called cloudformation JSON, which is the first thing we looked at. And then it uses the Amazon CLI to deploy it, pointing to that JSON file with a specific stack name, which is defaulted to Chippy Love. And then once it's deployed, once this is done, it will actually hang while it's deploying. We run this describe stacks to try to extract the IP address. And if you're not familiar with JQ, awesome tool, but it basically allows you to take JSON and get things out of it in a nested way. So if you look, well, we can't look at, I don't have the output here, but this is getting the output of the IP address. A little janky, but it works. So let's go ahead and run this script. I've already all right. Let's hit deactivate. So let's run the script. All right, so there it is, installing troposphere into a virtual environment. So that is right here. And now this is starting to run this command here. It's already created this JSON file or overwrote it. I should have, bad demo, I should have removed that ahead of time. But it basically piped that into this file, and then we're going to deploy it pointing to that file. If I go back to my Amazon console to the CloudFormation portal, you can see, a little too much zoom, that there is a stack here called Chippy Love, create in progress. And if you dive into it, it'll show our template. So this is the JSON file that was created by Troposphere and passed through the Amazon CLI. This should look, here's that user data that attempts to start a web server, we'll see. And it also lists all the resources. So imagine you had, like, I'll just really quick, I'll jump here. I mean, look at just the sheer number of different Amazon fraud detector. I don't know, maybe you need that. I don't know, I've never used it. But there's all sorts of these different things that, that you might deploy as part of your stack. Right now, we just have an EC2 instance, which is the simplest thing. And it'll even give you links to go learn more about that thing. So if you go into here, it'll show you, this is the instance, that's the type we expected, here's its public IP. If I go back to my script, the last line is it extracts that public IP. And if I grab this and open it in the browser, crossing my fingers that the web server worked. There it is, there's our server. And now I haven't automated this, but what's really great about CloudFormation is you can actually delete the stack in one fell swoop. I don't have this in the script, I'm sorry, but you could use the Amazon CLI very easily to refer to this. You know what, let's figure it out. Probably just delete stack, yeah. So AWS CloudFormation, delete stack, -- stack name equals Chippy Love. That was mysteriously fast. And now you see it's deleted in progress. If I try to hit my website again, you see it's hanging because if I go to my instances, it's starting to shut down and it will terminate, and I won't end up paying for it all month. So that's that for the demo. Oh, I think I stopped sharing altogether. One sec. So yeah, again, if you want to see that code in action, you should probably just go to the troposphere examples. But if you want to see specifically what we just did, github.com/bloodorange.io/python-aws-infra-demo. And again, if you or your company is struggling to figure these things out and you might need a little help, feel free to give me a ping and we can talk business. And here's my website if you want to learn more about what we do. Thank you very much. That's all I have. Thanks for having me.
Awesome. Thanks so much. Can everybody give Josh a round of applause in the chat? I'm clapping right now in my apartment. So we do have a couple of questions. So actually, I'll start with the question. If you have, say, resources already out in AWS and you want to get them into CloudFormation, is there a way you can like back it out?
No, and that's not as far as I know. And that's part of the reason why you really do want to use CloudFormation. The alternative is using, writing your own thing to do CloudFormation, like a bash script, or troposphere, or not troposphere, Terraform, HashiCorp Terraform, which might have more options for that. But in terms of pumping something into an existing thing, I've had a bad time with that.
Okay. Yeah, I do know, like, I've had some experience with Terraform with like their Terraform import command. I was able to do it with my AWS and DigitalOcean. That was pretty cool. So there is a question by T. You actually just gave him a shout out in the talk. He's out there watching. So he's wondering, what does Troposphere support in terms of new features for CloudFormation?
That's a really good question. That might actually be one downside to Troposphere, is that you would probably wait a week or two for that to hit a new release, because they are classes, as far as I understand. They may have a way that you could create your own. To be frank, I don't use Troposphere all the time. I just thought I just think it's super cool. But again, it's just JSON. So if you import the standard JSON library in Python and inject something in there, it should work.
Awesome. And if anybody does have questions, please ask them down below. T actually had a second part to his question. I don't know if you're familiar with the CDK Python, which is like, I believe, AWS's cloud development kit. Do you have any opinions on how it compares to Troposphere?
Let me pull that up. I have not used this. It looks quite similar. No, I don't know. It might be a newer thing that I'm not aware with, and might actually be a better option. Sorry, I don't have much more to add there.
No, there's definitely a lot of options in the space. I think that's like one of the things. Like, I really enjoyed like watching you. Like, you're like, how do I use the CLI for AWS? And it's like, those are one of the things like I'm always scared of. So it's like I always enjoy watching people live code. But I think you also recently started live coding. Can you like tell folks about that? How they can like follow you on Twitch?
Yeah, thanks for that. So once the COVID stuff sort of hit, I felt a kind of call to action, sort of, at least at first. And I wanted to help people who, especially, from different industries that are really hit by this, like restaurants and bars, that if they're just, if you're just at home, not sure what to do or when the ban and everything's going to be lifted, that you could learn, start to learn some new skills in industries that aren't hit so hard, such as software development. So yeah, if you go to twitch.tv/jdolitsky, I actually have done already 2 live streams that are recorded up there. They're a little rough, but it's starting from scratch, no prior knowledge of any HTML or anything, how to do web development using nothing but like the browser and Sublime Text. So yeah, if you know anybody who's in a really bad situation and is trying to break into this field, definitely please send them my way, and I'd love to help them out. And I think for the third one, I was actually thinking of doing starting to do some backend stuff with actually Python web server.
That's awesome. It's like, it's really great to see like folks coming together, and like community is such a big part. Like I know like you're really involved, like, especially in the Kubernetes community. We actually also frequent the same open source user group like once a month and do our hackathons. Like that's always fun, always good to catch up there. There was one more question in the chat. So this is for specifically troposphere, if you want to talk a little bit more general, but how would you go about testing your like infrastructure as code scripts?
Yeah, I don't know if Andrew's still here. He might be better to answer that. But so at the end of the day, this is creating a JSON string. So a really simple thing you could do is write a test to send the JSON into a variable, and then parse that back into a Python dictionary or Python object using just the JSON dump or JSON load rather, and just like iterate onto some nested field and make sure it's there. That's one way you could unit test that your JSON is actually being generated simply. Or if you are into Bash like I am, I would use JQ.
Yeah, that definitely makes a lot of sense. And I think like if you really want to spend some time, you could probably like write up a little bit of like a test simulator that spins up like test infrastructure and use like CLI to sort of like make sure things are working like in a sanity check.
Yeah, and that actually that points on to, you know, CI type stuff. If you go to my repo that I shared, there's actually GitHub Actions to run all that stuff. And this is a very, you know, a real world use case of how you would do continuous deployment of your code.
Awesome. Well, thanks again. We really liked having you on and learned a lot about CloudFormation. Before we do let you go, do you have any words of wisdoms or action items for our community?
I would just say, you know, this is a crazy time, and I really miss going to the real meetup, because as much as I love the talks, I love to, you know, catch up with everyone over some pizza and that. So it's a real shame, but please stay positive, support one another. And I'm always here if you want to just talk about non-code things too. So
thank you. I really appreciate you making yourself available to our community. Can everybody give Josh one more round of applause in our chat? It's great, great having you.
Yes, thank you. Thanks for including me.
All right, man. I will hopefully see you soon at one of the open source meetups.
Yeah, hopefully.
All right, man. Take care.
All right, bye.